So the experiments in Machine Learning Studio are created in the special window, and they allow you to move the data sets and to move the blocks with the machine learning algorithms. So here, as you have already been familiar with the screen experiments in your Azure Machine Learning Studio, in the left bar here you could choose the machine learning algorithms or the data sets to put it into the working space. So the important features, so what you need to do is you can use the sample data sets here from the saved data sets, samples. Here is a list of already prepared data sets that you can use in your experiments. And you can also choose these data sets for your individual work if you want. So you can import it from this part of the screen. So here is a very popular example of the IRIS2 class data where you will classify these iris flowers according to their features into the two classes. So here it is also written that the circle here by the 1 number is the output port that you will connect to the new block. So you can also visualize what is represented here, and in the window you will have the following list of features. As you must be already familiar with this part. So here it is. It is sepal length, sepal width, petal length, petal width. So there are 4 features. You have 5 columns with 4 features and the class. So according to the values in the of all the 4 features, you will classify these 2 flowers as 0 and 1. So here we can classify it as iris flowers or not iris flowers. So and then we can provide the statistics in the graphs. So for the next part, you will need to split your data set as a training and test part. So you should be already familiar with this part as we have talked much about it. So how do we usually split our data set? In what proportion? Do you remember it? Training and test part. So how, in what percent do we usually split this data? Could you tell me this? Okay, if you don't remember, we usually split this data into the 70 to 30% or 75 to 25 and sometimes 80 to 20%. This is a commonly used training and test split. But you can also, in other cases, use another. If you have a very large data set, you can put a smaller part for training data and more data for test part. But if you have a restricted number of data, it is also preferable to put as much as possible for the training part. So here is the data split. This is the percent that we have talked. Here is the 0.7. So it means the 70% are going for the training part. The next part is the data normalization. As you have seen, the data in the features, its values can be represented in completely different range of values. And sometimes your algorithms don't accept these kinds because they must be normalized to the way in which they have the same scale for all the features. Like here, we can see that logistic regression and neural networks work quite well when the input variables are scaled between 0 and 1. So it is preferable to input the data from this diapason of values. With the scaling from 0 to 1, we have the minimum 0 and the maximum 1, and the other part will be the these floating point values between these scales. So they are scaled proportionally when you normalize the data. So you use this block normalized data that you must find it in the data transformation part, the data transformation normalized data. Then in the next part we must choose the algorithm that we will use for the classification. There can be different kinds of algorithms, machine learning algorithms, starting from logistic regression and ending to the decision trees. So around the 5-6 commonly used machine learning algorithms, and you can also use neural networks for data classifications. As these two approaches are mostly used today in the machine learning assignments. And here, as we have two classes, so depending on how many classes you have, you can have more than two classes, then you use a multi-class logistic regression. So it will use a so-called k-fold method to classify the data. But if you have only two classes, it is also preferable to use a two-class logistic regression. Like here, you will use this, you choose the machine learning algorithm to class logistic regression, then you connect it to the cross-validate model, where the first input accepts the machine learning algorithm and the second input accepts the normalized data from the previous block, as you see here. And you can also choose the columns you want to use for data classification. As you have a list of features, and if you don't want to delete them from your model, but at the same time you don't want to use them in your classification algorithm, so you can get rid of them and don't include in the model. So in this case, you can use a column selection. So here is a list of them. What column names you want to include. Then you run the model and you see what you get. We visualize them, and uh, the commonly used metrics like area under curve will help you to understand how well your classification was realized. So here they also use a neural network approach. As you didn't have the special course, you can use only this block for to have some idea how the neural network works. You can visualize it as a net with the nodes that are neurons, and to these neurons you have the input data, and these parameters are trained when you launch your neural network and input here enough data for it to train well. This is a little bit different. For neural networks, uh, one of the most important feature is to have as much data as possible because it influences the results of classification greatly. So as you see here, it has the neural network has many hyperparameters. You can choose them to configure your neural network. Like this, you have the number of hidden nodes. So it is a intermediate layer, and in the intermediate layer, you choose as many nodes as you need. So the number of iterations and the learning rates are also the hyperparameters that influence the model greatly. The learning rate is usually from 0 to 1, and the number of learning iterations is the number of epochs, and here you can choose the value more than 1. So here also represented uh, the images of the how you visualize your scored model. So here we can see that the sepal length, sepal width, petal length, and petal width are the normalized values from 0 to 1. And here you can see the scored labels and the class. So here are represented the initial classes, so to which these classes were allocated according to the some biological features, and this work is usually done by human. So it is called the supervised machine learning, where on the first step the experts mark down the classes of all the data that they have, and after they allocate, you can use them to train the model. So the experiments label the data, then you use this data to train your model. And after testing, you can see like these score labels. So here, when this class, when the class that was initially allocated for this for this flower, for this data row, and the score label, the class that was labeled by the machine learning algorithm. So the result of it, if they're different, it means that your machine learning algorithm misclassified the data set. And it is a normal practice when you uh, don't have all the right all the right classified data values. Because if you have like 100% accuracy of classification, it means that your data the machine learning classification model has the overfitting result. It means that it is trained too much, that it memorized all the nodes that were initially labeled. And but when you so it is good for this data set, but when you check it on and when you check it on additional data, it can show you much worse results than you have received it on this training data set. And if you have like the very low accuracy, it's also bad. It means that you don't have enough data to train your model well. So everything that is very close to 100% and then is much below 50%, it means that you have the problem with your data set or the model you have chosen. But in many cases, there is a problem with the data set. So there is a common problem. Like here you see the accuracy, the raw curve is close to 1. So it means that probably this model has the overfitting result. Usually this raw curve on this image like this, so it should be like this is the direct line. It should be above this line, but not exactly at 1, because when you have this model at 1, you should be very attentive that something in your model is not right. So be aware of overfitting or underfitting when you don't have enough data to classify your model well. So these are like the key features of machine learning algorithm. And you need to be attentive about your classification results. So did you understand this? Guys, anything about
Yes.
here?
Yes.
So did you try your experiments in machine learning Azure Studio?
I will start today.
Okay, did you get such results like this about the raw curve, the area on the curve like this for your visualization? What was your result if you tried it? Yeah, okay. If you haven't tried it, use the model evaluation for data classification. Like this, you can use uh, binary classification, or you can also use a multi-class classification for your data sets, and just try to use these data sets from the samples that you have. Uh, I don't mean that you must be very familiar with how these data sets are annotated, how they were labeled, and some very deep features about the machine learning algorithms like this and the neural networks. Just in this way, it is good that you don't need to code everything because we need to, in this case, we had to start from uh, just the coding in Python like this, started to use some libraries to insert the data, then to normalize it, and then to use just the library with the prepared machine learning algorithms. So in this case, you don't need to use it. But the good way is that you can practice in the clouds, and it is just free for you to get some basic ideas how machine learning algorithms work. And if you want to get more information about it, because this field is very popular now, and it is this is why I want you to have some basic if you are very interested in it. uh, you can practice more, find additional materials now as you have more time, more free time. You will have more free time in the next months, and you can also use it for your final course work when you will write your diploma work. Maybe you will need to use something like this, and it is a good way to have you practice here. As we have this course of cloud computing, I wanted you to be familiarized with the concepts of machine learning and how you can use the cloud technologies to experiment with these training and testing data sets in machine learning Azure Studio. So now I want you to have this practice and to show me your results in your individual student work.